I'm Anil Kumar sharing with you a last minute video which is for some of my students who have final exam tomorrow. So all the best to you. We'll discuss these three questions and we will also understand basic concepts to solve polynomial inequalities in this particular video. I have taken up questions which are quite difficult. That's why I mentioned level 2 here. You can also look into the playlist which I have on this topic for extra practice. Question number 1 is, write a quartic function f of x such that f of x is less than equal to 1 when x equals to minus 5 and when x is between 0 and 4. Question number 2. Write a linear function g of x such that it is greater than f of x equals to 4 minus x squared when absolute value of x minus 1.5 is greater than 2.5. Now in question number 2, we have involved three different functions and you have to write equation. Now this question is very important. If you really understood the concepts, you should be in a position to do it. Question 3. A square-based pyramid has a height that is twice its base length. What is the domain and range of the function if the base must be at least 1 centimeter and volume cannot exceed 80 centimeter cube? Okay, let me tell you that as far as the volume is concerned for such shapes, whenever we have a pyramid kind of a thing, just make it 1/3 of a cylinder in that shape, in that base. You get my idea. So it is square based, has a height that is, so basically square is x is the base, x square times height. That becomes the volume of the square based thing, correct? So I hope you understand the concept. We are saying that this pyramid is kind of square based, right? So that is the square base. So assume that we have a cylinder. Assume that. You understand? Assume you have a cylinder. So what you have here is a cylinder. And within that cylinder, you make your pyramid. That is, your height is kind of same as the cylinder, right? So join this point with all these 4 points. So you get this pyramid. So volume of this pyramid is 1/3 the volume of the cylinder if the sides are, in this case, h. Is it okay? So that is how, if you get some shape and you don't know the formula, you can make up this formula like this. Pyramid will be 1/3. Think like this. 3 can fit into this space. Okay, I hope that makes sense. Right. Now here we are also given a condition that pyramid has a height that is twice its base. So we know height is twice x. So we get function volume as a function of x. Perfect. So I like you to copy these questions, solve, and then look into my solutions. I'll first take a basic understanding of polynomial inequalities, as that may be required for some of my subscribers. So when we solve polynomial inequalities, we have two options. One, we could do using graph, right? And the second one is we can use a table. Right, so I'll show you both with the help of examples, and then we'll take up solutions for these three questions. So let me talk about polynomial equations and inequalities a bit and make up a question for you. So we say, let me write down a function here, x minus 3, let's say, to the power of 5, and we have x plus 2 to the power of, let's say, 4. Right, and let me just write x here, right? So basically that is my function which I just created. We need to make an inequality. So let's say we want to make it greater than 0. When we say greater than 0, it does not include zeros, right? Now we'll do it by graph. See how to do it with graph. It is not very difficult and it will help you review the concepts. So okay, so let's sketch the graph for this particular function. We begin by writing the zeros for the polynomial, and as you know, the zeros are first 0 at x equals to 3, and this is the order of 0, so it is of order 5. Whatever make the factor 0 will make the function 0. This one is at minus 2 and the order is 4. That means it will turn. And here the order of the 0 is 1, x to the power of 1. So it is at 0 and the order is 1. Right, so these are my zeros. Let us look into the degree of the function, right? 5 plus 4, 9 plus 1, 10. So we have even degree, which is even, right? And leading coefficient, let me call an, which is positive, right? If you multiply all these coefficients, you get positive number. So that gives you the end behavior of the polynomial. Even means, first let's begin with here. Positive leading coefficient means right up, right? So this means right up when you sketch. Now, and when we say it is even, even means same side, both ends, same side. So if right is up, left side will also be up. That is what I mean, correct? And now let's mark the zeros. So zeros are at 3 minus 2, and let's say this is minus 2 for us. And then we have 1 at 0, and let's say this is 3 for us. These are my 3 zeros. Now at each 0, let us mark the type of 0 it is, right? So what type of 0 it is? So what we see here is that first one here at minus 2 is 4, right? So it will reflect from here, kind of a parabola. At 0, it's linear. You're on this side, so you'll go down straight. And this is 5. You're here now, so you'll go like this curve. Is that clear to you? So once you have all that information, you can clearly sketch your graph and connect these points, right? Connect these points, so we get these points connected. Okay, and then you see how this graph has been created? So that is the graph for you. So from the graph, we can easily answer the question, that is this inequality. So we have y value here, x value here. We want to know when is this polynomial greater than 0. So clearly the solution is visible to you now. Perfect. So what you see here is the interval where x is greater than 0. So all this portion, x is greater than 0. Here it is greater than 0, and also at this side it is greater than 0. And so you could write down your solution that the answer here is from minus infinity to minus 2. Do not include minus 2 since it is greater than 0. Do you get the idea? And then union from minus 2 to 0. Do not include those zeros. And then union after 3. Correct? It is greater than 0. So we say 3 to infinity. So that becomes the solution for the given inequality. So I hope that is absolutely clear. Now here is a test question for you. Now you can adopt the new method and also practice with this graph. So what I'm going to do here is give you a kind of tricky question. See how I'm writing x square minus 1, right? So x square minus 1, I'm writing this as whole square. And then I'm writing, let's say 2 minus x whole cube. Okay, so I'm only taking 2 factors, and this time let me take less than equal to 0. Perfect. Now we'll use the table to solve this polynomial inequality. So what you should do here is basically rewrite the function in the correct way so that you could read properly the actual zeros and also the leading coefficient. Now, degree of this polynomial, let's begin by answering what is the degree of this polynomial, right? So let me write down here, what is the degree? So degree of the polynomial is 3, and this becomes 2 times 2, 4. So degree is 7. So this time we have taken odd function. And what is the leading coefficient? Is it positive or negative? Well, this part is positive. Minus x cubed gives you negative. So that is a trick. So it looks as if it is positive, but it is actually negative. Right? You see that part. So I think you have to be very careful in test questions. This portion here could be written as negative of x minus 2 whole cube. See, negative cube is negative, and therefore this could be written as this, right? And we can now factor x square minus 1 whole square as what? We could write this as x plus 1 square times x minus 1 square, and that becomes your polynomial inequality. Do you understand? So if you factor this, you get x plus 1 times x minus 1. Whole square means both are squares, right? Now again, let's count. 2 plus 2, 4. 4 plus 3 is 7. So the degree is 7, right? And the leading coefficient is negative and not positive. Now these kind of questions could come in multiple choice questions and so many other ways. So these two are very important. Now let me share with you the method of making a table and then figuring out the solution of inequalities, right? So we'll do that. So what we see here is that we have zeros at, so let's write down our zeros. So we have zeros at what point? At 2 we have a 0, and we have 0 at minus 1 and also at 1. 2, the multiplicity is 3. At minus 1 and plus 1 it is 2. Right, so these are the zeros like this, which will divide your line or interval or domain in intervals where you could have solution. So 3 zeros means 4 intervals, right? So let me draw these 4 intervals. So we have, let's say 1 interval, 2 interval, 3 interval, and let that be the 4th interval. So these points here are showing demarcation for your zeros. So the first one on the leftmost side is at minus 1, then we have at plus 1 and 2, right? The factors which give you the zeros are written here. So what we do here is we write all the factors. So minus 1 factor is x plus 1, I'm changing the order now, and it is whole square. The other factor is x minus 1 whole square, and the third factor is x minus 2 whole cube. Now this negative could be included with any of these factors. However, I will include it with the last one here. So we'll see the sign of each in different intervals, and then we can solve. Let's take test points in each interval. Let the test point be minus 2, here 0. We could take 1.5 and 3 as the other two test points. Now these things are squares. It's kind of simpler. So squares will always be positive, right? So you don't have to really bother about these. They will always be positive. Now that is the tricky one. Here we have negative outside. So if I put a negative 2 here, we have negative q, which is negative, but that makes it positive. So this becomes positive. Do you get this idea? Right? Substitute a value of x. Let's say now we substitute 0. Minus 2 cube is minus 8, and minus 8 and minus makes it positive. Do you see that? So that is it. And if it is less than 2, then it is going to be negative inside, outside negative makes it positive, and here it is going to be negative. So what we see is that for our given polynomial, we will have positive, 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 and negative as our graph. Now, using the method of graphing which we just did, let's confirm our result. Okay, it is odd degree. Opposite ends, right side will be decided by leading coefficient, which is negative. Negative means right down, right? Right down. Since an is less than 0, negative. Do you see this portion negative? Okay. So right side is down. So when you sketch this, your graph will be kind of at this point, and so the rightmost is because of the cubic function. So it's going to be kind of like this. Do you see that? Now the other two are positive, right? opposite ends because this. So when you graph it, so it will be like this. It'll turn here, right, and go like this. So as you can see, it's positive all along. We are looking for solution when it is less than equal to 0. So now, can you write down your answer? Well, clearly the answer is what? First, since it is equal to 0, we are going to consider these points also as a part of solution. So we have definitely x is equals to -1, +1, and 2. Zeros are included. Do you understand? Well, and the last thing is, here it is less than 0. So we have x is greater than equal to 2. So you need not write 2 here. You can include this right there. So that is the interval where the function inequality has a solution. Do you see this part? So the solution is right there before you. So it says these points are included, the zeros and this interval. Perfect. We are looking for less than equal to. So I hope the general method, both these methods are absolutely clear. And now we are in a position to take the challenge questions which we have here. So I hope both these concepts are clear and you're ready to take up the challenge questions. Now let's take these challenge questions one by one. Have a good look at what we just did. Okay. So the very first question here is, write a quartic function f of x such that f of x is less than equal to 1 when x is equal to -5 and x is between 0 to 5. So we are given a function, quartic function, which is less than equal to 1, right? And the solution for this is, okay, and the solution for this is x is equal to -5 and x is between 0 and 4. Do you understand the question? Now we have to figure out what the function is. Correct? So that is how the question has been framed. Now how do we do it? So what we can think about is we need to write the function. Let's bring 1 to the left side. So we get f of x -1 is less than equal to 0. Right. So let's think about it like this. So bringing 1 to this side will make that less than equal to 0. So f of x -1, let's call it another function, g of x, right? G of x is less than equal to 0. So we'll actually get the function g of x, and then we'll take away 1 and then get f of x. Is that clear? Right, so that is how we'll do. Perfect. Okay. Now let's see how to do it. So I'm going to use the technique which we have just learned, and that is the graphing technique. So what we are saying here is, if I make it on this side, the inequality remains same, but the solution is that one point is at -5 and the other one is in the interval when it is equal to, it should have been equal to here also. I'm sorry. So let me change the question. When we are saying equal to, this inequality should have been greater than equal to. Is that okay? So the other interval is from 0 to 4, right? So our solution on a number line is this. That is the solution on the number line. Since it is quartic function and we are saying less than, right? So that means during this interval, the quartic function is less than. Correct? Less than. So that means the function must be going like this, right? So let me sketch a function which is less than in this interval. So it has to be kind of like this. Does it make sense? Now here it is only equal to -5 at this point. So basically it should be something like this. Does it make sense? So that becomes the quartic function which can meet the requirement what we are looking for. Perfect. Do you get an idea? So if this is the quartic function, We could write this function g of x as, or rather the inequality, which gives you that solution, right? Which gives you this solution. We are looking for the solution right there. So the inequality using these zeros, this is kind of a double zero, right? So we get x plus 5 whole square, right? And here linear zeros means x, and this means x minus 4, perfect, is less than equal to 0. That becomes g of x. That becomes g of x. So what is f of x? To get f of x, we have to just write minus 1 here. Is it okay? So g of x is basically, so what we have here is that g of x is basically equals to f of x minus 1. Oh, I'm sorry. So what is f of x? F of x is equal to g of x plus 1. So let's add 1 to this and write down our functions. We need to write the quadratic function f of x. Do you get the idea? And so the answer here is that f of x is equal to all this, which is x plus 5 whole square times x minus 4 plus 1. Do you see that? Plus 1. So that becomes the function f of x, because in the case of f of x, the inequality was less than equal to 1. Does make sense to you? So that is the solution. So here is a very concept-based question. So I hope the steps are absolutely clear and you understand the whole process. Okay, now let's take up the next question. I'm Anil Kumar, sharing with you a thinking question on polynomial inequalities. Now this is one of the best questions you can get on this topic. Question number 2. Write a linear function g of x such that it is greater than f of x equals to 4 minus x squared when absolute function x minus 1.5 is greater than 2.5. So we are relating three functions in this particular case and then trying to find the solution of an inequality. I'd like you to pause the video, answer this question, then look into my suggestions. Let's try to understand. Write a linear function g of x. So g of x is a linear function. Let's call this as ax plus b, right? Such that it is greater than f of x. That means we want g of x to be greater than f of x. And when do we want it greater than f of x? We want it when absolute value of x minus 1.5 is greater than 2.5, correct? So that is what it is. So let us begin by solving the last inequality, which is x minus 1.5 is greater than 2.5, correct? So when we say the absolute value is greater than this inequality really means what? Let's look into this. So it means that it means two things. Let me show you those two things here and then we'll get back to the question. Because an absolute function, it could be positive or negative, right? So it really means, if you want to do algebraically, it means that x minus 1.5 is greater than 2.5. If we are talking about x being greater than equal to 1.5 when this portion is positive. Is it okay? However, this also means that when x is less than 1.5, it becomes negative. So we have to take negative of this. So the absolute function can be written as minus of x minus 1.5, right? So is greater than 2.5. Do you see that? Minus of that. So these are the two inequalities you have to separately solve. So here you get x is greater than 2.5 plus 1.5. That means x is greater than 4. In this case, that minus makes inequality flip. So we have x minus 1.5 as less than minus 2.5, correct? When you multiply by minus, you have to change the signs. So that means x is less than minus 2.5 plus 1.5, and x is less than, if you do this, what do you get? You get minus 1, correct? So basically it means that on a number line, I could solve this inequality and show my solution kind of like this. From the x absolute value, that if this is 0, for example, then we're looking for a solution in this portion. Do you see that? Well, this point is at minus 1, this one is at 4. Correct? So that is what is to be interpreted from the given condition. Now let's get back to the question. So in the question, it really means that we're talking about two things. One is this parabola, which is opening downwards. So let me make a sketch here to show that. Okay, so let's do it here. So we have a parabola opening downwards, where this portion is at 4, right? And what? And we have that a line, g of x is a straight line, which has that solution. G of x is greater than, that means if I draw a line, so line is above the parabola when the values of x are on the left side of minus 1 and right side. That means if I draw a line like this, for example, right, then we are saying that the solution is not this. Here line is under, right? Here the line is above. Do you see that? This is the solution. Do you see that? This is the solution. So the value of any point is greater than on the line, greater than that on that. This is g of x, right? And this is f of x. Do you see that? So g of x is greater than f of x, where these points are the x values, x equals to minus 1 and x equals to 4. Do you get an idea, right? So basically we are saying that g of x is a straight line. So this implies that g of x is a straight line through x equals to minus 1 and x equals to 4. Perfect. And those points of intersections are on the curve. So let's find these points. So f of minus 1 is what? So you get 4 minus 1 square, which is equal to 4 minus 1, which is 3, right? The other value is at f of 4, right? So the other value is f of 4, and at 4, the value will be 4 minus 4 squared. That gives you 4 minus 16 or minus 12. So that means g of x, we could get, it passes through point A, which is minus 1, 3, and B, which is 4 minus 12, right? So that is how you're getting the line, correct? So we are saying that g of x is a line which goes through these 2 points. So now it is easy. We can find the equation of this line. So first step is, of course, to find the slope m, which is y2 minus y1. Okay, so we get minus 12 minus 3 divided by x2, 4 minus 1 makes it plus 5. So what we get here is minus 15 over 5, or negative 3. So negative 3 is the slope. So the equation of the line could be, let's write just y here, minus 3x plus b. To find the value of b, we'll plug in the point. Perfect. So let's do it. So I hope it's clear. So let's put b, which is the second point, minus 1 and 3 is good. So like 3 for the y value, right? Minus 3 times minus 1 plus b. Bringing it to this side, we get 3 plus 3, which is 6. So b is 6 for us. Since b is 6 for us, we can write down the answer. G of x is equal to minus 3x plus 6. Do you see that? So that is how we get the solution of this particular question. So go through this question once again. Write a linear function g of x, that is your linear function g of x, such that it is greater than f of x, the parabola inverted, when x is less than minus 1 and greater than 4, right? That is what is meaning of this absolute function inequality. Bring them all together. So that is what is expected for you to know when you enter for final exam on pre-calculus advanced functions. So I hope this concept is absolutely clear. Have a good look at it. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that will be great. I'm Anil Kumar, sharing with you an excellent question on polynomial inequalities. We are almost at the end of the session, where the exam round the corner. Question number 3 here is, a square-based pyramid has a height that is twice its base length. What is the domain and range of the function if the base must be at least 1 centimeter square, at least, right? So base must be at least 1 centimeter square, and the volume cannot exceed 80 centimeters square, right? That's the question for you. So let's try to understand what the question is. Let's say we have a square based, that is the base square, right? Pyramid. So we'll take a point on top and join with these points. So we get a square based pyramid. Now what is the expression for volume? For any pyramid, if you consider a cylinder, it is 1/3 of the cylinder. So we can say volume is 1/3 of area of the base. These sides are x for you, so which is x square times height. Now in this case we are given, so let's say this is your height, right? So here the height h, you're given that the height is twice the base length, so height is 2x. Since h is equals to 2x, we could write this volume expression as v equals to half of x square times 2x. Oh, sorry, 1/3, sorry. 1/3 of x square times 2x. Is that clear? So think as if 3 pyramids can fit into this box. Is that okay? 1, 2, and 3. Think like this. Then it's easy to remember or make up a formula, right? So we have the formula straight here. So we say volume as a function of base length is equal to 2 over 3 x cubed. Is that portion clear? Right? Units are in centimeter cube. Now, we need to find domain when it says that the base area is at least. That means area of base is how much? Is x square. So we are saying that x square has to be greater than equal to 1. So that is your domain, right? So that means the minimum value is x equals to 1, correct? So that is to say, that gives you the minimum value that x is greater than equal to 1. Is it okay? Now, how do you get the maximum value? So to get the maximum value for x, we are given the volume. So it says the volume cannot exceed 80 centimeter cube. That means the volume expression, which is whatever, is less than equal to 80. So that gives you the maximum portion. Do you get an idea, right? So that is to say that 2 over 3 x cubed is less than equals to 80. So you have to solve this inequality. Okay. Since we are working with positive values, we'll only concentrate on positive answers. Right? Therefore, we didn't consider any negative value here also. So we have x cubed, which is less than equal to 80 times 3 over 2. Correct? So that means, let me do it on the right side, save some space on this. So what we have here is that x is less than equal to, you could simplify this 40, and which is 120, right? So it is x is less than equals to cube root of 120. Perfect. So let's find cube root of 120 and write down our answer. So we get the maximum value for x. So we know the domain now, right? So we have cube root of 120 equals to 4.93. Okay, so that means x is less than equal to 4.93 approximately. Does make sense to you. So that gives you the domain, right? So we can write domain of the function is x belongs to real numbers where x is greater than equal to 1, less than equal to 4.93. Now let's talk about range. So basically we have x value which is between these two limits, 1 and 4.93. So what is the volume for these limits? That's what you need to figure out, correct? So let's find the volume for 1. So volume for 1 is 2 by 3. And let's find volume for 4.93. Rather, cube root of 120, right? So for this, it is 2 over 3 times 120, correct? Right, we know that volume. Maximum volume is 80, so you'll get 80 here. Is it okay? So that is how you get the volume. So volume is range, correct? So the range is basically volume for us. So as a function of x is, we can say volume is all real numbers where it is greater than equal to, so we say volume is greater than equal to 1 or 2 over 3, I'm sorry, 2 over 3, okay, 2 over 3 and less than equal to 80, which is given to us. If you calculate back, you'll get the same value. Perfect. So that is how you're going to answer this question. So in the question, you are actually given one limit of domain, the other limit of volume. And if you combine, relate these two, you get the limits for both. I hope that makes sense. That brings us to the end of this polynomial inequalities review. And I hope with that you learn something new before getting into your final exam. Thanks a lot and all the best.